Alright, so in this video we're starting to talk about factoring, and I know a lot of people really dread factoring, but it's really not that bad. So in this particular problem, our particular video, we're talking about the factored form of a polynomial. And almost every single polynomial can be written in factored form. And factored form looks similar to this, where n is the number of roots, or the highest degree of the polynomial, whatever you want to call it. Okay, they essentially mean the same thing. The a out front is your scaling factor. It's going to affect how skinny or how narrow the graph of the polynomial is going to be. And here R1, R2, R3, all the way up to Rn. Those are your roots, your x-intercepts, okay? So we're told that we have a polynomial p of x that has 3 zeros. Again, the word zeros is just synonymous with roots, which is also synonymous with x-intercepts. So we have 3 x-intercepts, or 3 roots, x equals 1, x equals 2, and x equals 3. What we're being asked to do is find the equation of the polynomial if we're told that p of 5 is 48. So we're going to start off with the factored form of the polynomial. There's 3 roots, so I'm going to start off with x minus r1, x minus r2, and x minus r3. We know we need some kind of scaling factor a out front, and this polynomial's name is p of x. So this is just general. We haven't really done anything yet. What we need to do now is everywhere I see an r1, r2, r3, I'm going to plug in my roots. So I have a equals x minus 1, x minus 2, and x minus 3. That information was given to me. This is still p of x. Well, I still need to find out what this scaling factor is, because until I get very specific about a, my graph could be very, very different depending on what a I select. So we have to use this piece of information here. When I plug in a 5 or an x, everywhere I see an x, the output that I get is going to be a 48. So everywhere I see an x now, I'm going to put in a 5, and it's going to make this whole thing become 48. So I have 48 equals a times 5 minus 1 times 5 minus 2 times 5 minus 3. Now I just want to simplify and clean it up as much as I can. So 5 minus 1 is 4. 5 minus 2 is 3, and 5 minus 3 is 2. Okay, 4 times 3 is 12, times 2 is 24, so 48 is equal to 24a, and we just get a by itself by dividing by 24 on both sides, so that means for this particular problem, a equals 2. So our final answer is going to be p of x is equal to 2 times x minus 1, x minus 2, and x minus 3. Now, we can verify that we have the right graph by actually putting this in our calculator. So what I'm going to do is go to y equals. If there's anything else in there, I'm just going to clear it out. I'm just going to type it in exactly the way it looks. So 2 times x minus 1 times x minus 2 times x minus 3. Okay, graph it. I can see what it looks like. And what I want to do now is go to the table. I'm told that I have a root at 1. So at 1, it's supposed to touch the x-axis, so my y value should be 0. Same thing for 2 and 3. Those are both roots or x-intercepts, whatever you want to call them. So at every x-intercept, the y value should be 0, which it is. And then finally, we were told in the original problem that when you put in 5, the output is 48, which it is. So we've done this problem correctly. So again, we just used our roots and plugged in a little bit of information to find our scale factor of a. And that's it.